Hello, today we'll be looking at the mathematical pendulum experiment. Mathematical pendulum experiment. So this experiment, our aim is to determine acceleration due to gravity, right? We are finding acceleration due to gravity for this experiment. So that's the main purpose. So the title is supposed to be an experiment to determine, or the determination of acceleration due to gravity using the mathematical pendulum. That's the title. So this is the equation they gave us. Okay, so let's look at the setup quickly. Let's take a look at the setup. So we have our stand, our bulb. Okay, this is our pendulum bulb, and then our thread, right? And then our stopwatch and the meter rule. Stopwatch and the meter rule. So first of all, we are supposed to tie this at one end, the thread, and then set it at 60 centimeters. So we'll be starting at 60. So our table is supposed to look like L in cm. The next thing should be T1, T2, and then the T average. And then we have big T equals to the T average over 20 oscillations, because we are using 20 oscillations. Then the next thing should be squared, T squared. Okay, so this is how our table will look like. So we are starting with L of 60, right? Then we oscillate this a very small angle. Then we count. Then we measure 20 oscillations. Then we do it again. So this is 1, this is 2, 3. So we do for another 20 oscillations, right? Then we record T1 and T2. Then we decrease the length, right? We decrease the length by 5, because the manual says we should decrease it by 5 centimeters each. So we're decreasing the length by 5 centimeters. We'll decrease it by the interval of 5. Okay. So this is the equation that was given. This is the period, this is the length, and this is the gravity we are finding. These are constants. So the first thing we need to do is to square both sides and then take off the square roots. Then we'll have an expression like that. But since they said we should plot, we are plotting T squared, right? We are plotting T squared against L. What we do is we remove or separate this to look like this. But of course, there is no plus 0 there. There is no plus C there, so it's 0. So the next thing we do is this becomes our Y. The whole of this becomes our slope, right? And then this L is what we are plotting on the x-axis. So that's how. So the graph looks like this. After finding our slope and our calculation, find our slope, right? Changing T squared over L, we equate the value of the slope to this, right? So we'll come and have an expression like this. So let's say if you had 10 for the slope, we equate this 10 to this, right, over G. So this is how you find the G. Now we make G the subject, we'll have 4 pi squared over the 10. So that's how you find your gravity in this experiment. Okay, and then at the discussion as well, we need to express the relation between the period of oscillation and then the length, and then also the period of oscillation and then the time. Okay, so that's how we do our setup. first of all, we hang our bulb, we measure 60 centimeters. Then after that, we oscillate it and measure our T1 and T2. Then we decrease this. We measure T1 and T2. We decrease it again, 5 centimeters till we get all our 5 values. Then we can compute the rest of the things on the table. Okay. Thank you.